All right, so here's the hexadecimal numbering system, and to get this system, you start out with your base, and my base is 16, so I do 16 to the 0, 16 to the 1, 16 to the 2, 16 to the 3, so on and so forth. And anything to the power of 0 is the 1 spot, so there's my 1 spot. 16 to the power of 1, that's 16, so this is my 16 spot. 16 to the power of 2, 16 times 16 is 256, so that's my 256th spot. 16 to the power of 3, that's my 4096th spot. 16 to the power of 4, that's my 65,536th spot. So you can see that this starts to scale really quickly. And two things to point out. It's called hexadecimal, and I already said this, but I'm going to say it again. It's called hexadecimal because hexa is 6 and decimal is 10. So it's the 10, base 16, it's 10 and 6, right? 10 and 6, base 16. That's where we get the name, hexadecimal. And then the second thing to point out is you can only have one digit in each of these placeholder spots. If you have two, the number won't make sense. If you have two or more digits there, the number won't make sense. You can only have one digit in each of these spots. So if we're going to represent 16 digits in that spot, we could use 0 through 9, which is the first 10 digits, and then we're going to use the letter A, B, C, D, E, and F for the last 6 digits, right? So this corresponds to the number 11. This corresponds to 12 in decimal, right? 13, 14, 15, and 16. 10, 11, 12, 13, 14, 15, right, is what it corresponds to. And so if I needed, like, you know, in hexadecimal to write the number 8, that's how I do it, right? I have 8 ones. If I need to write the number 9, that's how I do it. I have 9 ones. If I needed to write the number 10, that's how I do it. Whoa. Right? So it's just a numbering system. It's a coding scheme. You know, all of this is to represent a quantity. We've sort of naturally ingrained the decimal numbering system to represent or signify certain quantities to us. But we could do anything. We could assign any sort of, character to represent a certain quantity. I could say that this character, whatever that is, like in Chinese or something, represents the number 79. Whatever. I just made it up, right? Just like we say in decimal, this number represents this quantity, you know? And so now we're saying, hey, this character represents this quantity, which is 10. You know, so if I a quantity of 10 something in hexadecimal, I just do the letter A. And so it's a coding scheme representing the quantity of something. If I needed so here's the next question. If I want to write the number 13 in hexadecimal, what do I write? So pause the video and see if you can figure it out. How do I write the number 13 in hexadecimal? Here's the answer. This is 10, this is 11, this is 12, this is 13. Right there, 13. So I do this. That's 13 in hexadecimal. All right, so my next question for you, just randomly, we are doing 42 in all these. How would I write the number 42 in hexadecimal? So pencil that out on your piece of paper, the number 42 in hexadecimal, and then once you've got it or you think you have it, restart this video. Here is the answer, the number 42 in hexadecimal. Well, I need some 16s, right? So 2 16s will take me to 32, but 3 16s would take me to 32, 42, 48. That's too much, right? So I'll take 2 16s, please. So that takes me up to 32, you know. And then how far do I have to go from 32 to get to 42? I need 10, and this is how I do 10. So that's 42 in hexadecimal. So that's the hexadecimal numbering system. And the last thing to point out about numbering systems is you might be asking yourself, why? And why would I want to do this? Well, for hexadecimal, to represent like a large number requires less space. It requires less space. That's it. Right? So we could represent some massive number, and because this scales so quickly, we're going to be using less storage to store that number, and that can make us that can help us retrieve it and get the number faster and less disk space and all of that. And so because if I wanted to represent the number 68,000, I'm doing it just with those 5 spots. If I want to do 68,000 up here, right? Again, I'm doing it with just those 5 spots. But as you get higher, like this just keeps scaling, right? So what is 16 to the power of 7? 16 to the power of 7 is that number. Whoa. There we go. And 16 to the power of 7, so that's this spot. And it's there and there. So if I wanted to represent like 268 million and something, 260, let's say 268 million and 500,000, right? I'm only using these spots here. If I want to represent 268 million, well, I've got 10 millions here. That will take me up to 100 million? I don't know. Anyhow, as you get larger, you use less space. That's the point. So that is the hexadecimal numbering system. And here's the last thing I want to say about it. Binary, we use binary, the binary numbering system, and computers use it because it works really well with computers because they just have on-off states. And so it's really easy for us to encode numbers into binary, right? And so that's why we use the binary numbering system. So those are some of the reasons why we use numbering systems, different numbering systems, the binary numbering system or the hexadecimal numbering system. And that is how these numbering systems work. And that's going to be important for us when we look at coding schemes for text, like how do we represent text as on-off switches, because we're going to create a coding scheme which says, that, a letter A is like 32 or something. And so then we'll just store that as the number 32 in binary when we want to store the letter A. And, we're going to see that in the next video. But to understand that, you need to understand how we represent numbers in binary first. All right, so let's go look in the next video at text coding schemes, the way we store text characters in computers.